Hello, and welcome to the Computing Conversations column. This column is from the January 2014 issue of IEEE Computer and is titled Massimo Banzi, Building Arduino. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan. Most computer scientists focus on developing software and leave hardware development to a few specialist engineers. Designing and building hardware takes skill, patience, and time, which is why many software developers simply write code and use hardware designed and built by someone else. A microcontroller such as Arduino shifts this traditional separation, making it easier for anyone to build hardware. Developing something like a thermostat that senses when someone enters the room, for example, is well within the reach of any computer scientist. Not only is building hardware much easier and more fun with microcontrollers, it's also relatively inexpensive, which lets a wide range of engineers solve problems using a combination of custom-developed hardware and software. I met with Massimo Banzi, one of the co-founders of the Arduino project, at his office in Lugano, Switzerland, to understand how the Arduino was developed. In 2005, Banzi was working as a faculty member at the Interaction Design Institute Ivrea and teaching courses on interaction design for physical devices that increasingly needed electronic components.
When you do interaction design, there is this idea that you need to be able to build prototypes, because one of the, in a way, important elements of that discipline is being able to test the things you do with people. So, you want to make a website, you make a prototype, a mock-up of the website, you try it with people, you see how they react. And the same thing with physical devices. But physical means that you need to learn about electronics. So we had to create different classes that would basically make electronics approachable to people that don't have a background in electronics. They have next to zero software development background.
Because the course goals avoided teaching hardware development, Banzi wanted to make creating the electronic components for student prototypes as straightforward as possible. He also wanted the designers to be able to build, tinker, and evolve the electronic aspects of their work without depending on electronics experts.
So we had to make something that would run on a Mac, that would be easier to use, that would be cheaper than what was available on the market back then, which, and also we had this programming language we sort of inherited from the MIT called processing, which was used to teach about programming to artists and designers. So we thought, well, why don't we try to make that run on a microcontroller?
After several prototypes and a student thesis project on a product called Wiring that connected a microcontroller to a computer using USB and incorporated an API for easy programming, the first Arduino design was produced.
The first version of Arduino, which, based on the work that this student Hernando Barragan did on a project called Wiring, we re-implemented it from scratch. So we reused the APIs, but we rewrote the whole thing to be completely open source, because we also wanted something that would be easy for people to reproduce, to build upon.
Because the initial goal was simply to meet the needs of the design students, there was no plan to ramp up manufacturing in those early days. The team published the plans as open source and made a few printed circuit boards for their own use.
We didn't want to set up like a classic manufacturing company or go to a venture capitalist or something, because obviously back then nobody would have even talked to us. So we thought, let's release the hardware as open source so that people can build it if they want to. And we just started to make the PCBs of the sort of true hole version. And so we would just give them away to people as a gift. So just take this PCB, assemble one. And some people started to assemble it. So they went on the website, got the instructions, they started to write, to download the code, solder the boards.
Once the team had a solid design for the Arduino, they wanted to share their ideas more broadly. The next step was the first production run of pre-assembled Arduinos for their classes and workshops.
I originally started this project with a friend of mine called David Quartielles, who teaches in Sweden. And the two of us both had similar issues with our students. We wanted to, there was a bunch of input that we gathered, and so we started to make the first true hole versions. Then we met an engineer that was living and working in Ivrea that had experience in manufacturing stuff. He was actually helping me a lot whenever the school wanted to manufacture something with electronics. I would ask this, Gianluca Martino is his name. I would ask Gianluca to help me do that. So I said, well, can we manufacture 200 of these pre-made that we can just, sell to people? And then me and David managed to convince both Ivrea and the school in Malmo to buy 50 each. So 100 were sold, and then said, let's see if we can sell the other 100.
Arduino got additional exposure when Tom Ego started using it in his physical design classes at New York University.
And so we met him one summer in Italy doing a project together, and we showed him Arduino. He started to play with it. He thought, okay, I like this. We can go somewhere with this thing. So he brought back a few prototypes. We shipped him a few more boards, and he started to use it with some of the second-year students. And then at some point in 2006, I think the platform started to work properly. You could do good projects with it. And so the first-year students, they saw what the second-year students were doing, and they said, well, we want that Arduino ourselves. So I would say that kind of gave us 120 power users, people who make beautiful projects, and designers have this feature that they tend to take their projects and document them very nicely, put them online, because it's their portfolio.
As the clever design projects based on Arduino made their way around the internet, the demand for the microcontroller began to grow very quickly. Banzi made arrangements to distribute Arduino through the SparkFun online electronics store, which made it so the microcontroller was readily available in the United States. In a sense, Arduino is a self-marketing product.
But then it was a lot of people making projects, documenting them, putting them online, and then sharing information about how they built the product.
The maker and DIY movements have also adopted Arduino, and it's increasingly used to introduce young students to technology to give them a sense that they too can understand how hardware and software combine to produce new technologies.
Well, with Arduino, the idea is that you download a file, you plug the board. Okay, back in the days, you had to install a few drivers, but then, in the space of an hour or something, you were working.
You got a blinking LED?
Yeah, the blinking LED is the hello world. The blinking LED is the hello world of physical computing.
Arduino's worldwide popularity lets Banzi and his co-creators spend time thinking how to get young people more involved in the design of our everyday technological devices.
And I think it's important, especially for kids, for them to understand that the world we live in, now especially if you look at this room, this is a building that was designed by human beings, built by human beings. Every single bit was designed and built by a human being. So clearly, if you know how to design and build things, you can affect the world that surrounds you. If you are not able to participate in this, in the world of creation in the digital space, you're left out. Somebody else is going to design your world. At some point, if there's no innovation, if there's no sort of renovation in a way inside the marketplace, then one company decides that that's the way you do a certain thing, and that becomes the only answer to a certain question, and nobody starts to debate that. Or, in a way, I think it's important to be masters of the technology.
While Arduino was originally conceived and designed to help in the creation of design prototypes with electronic components, it has the potential to bring hardware elements to teaching at all levels of computational thinking and computer science. This column is from the January 2014 issue of IEEE Computer and is titled Massimo Banzi, Building Arduino. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan.